What if I told you that every single motorcycle engine, no matter how big or small, how refined or raw, is essentially a carefully orchestrated symphony of controlled explosions? We're talking about these detonations happening not just once, but thousands upon thousands of times every single minute, powering your ride. It sounds intense, and frankly, it is. When you stop and think about it, you're literally sitting astride a machine that's a marvel of engineering, a testament to human ingenuity. It's a powerful beast, a sophisticated piece of machinery that has decided to dedicate its existence to the noble purpose of transportation. Pretty wild, right? And today, we're not just touching the surface. We're diving deep, dissecting and demystifying every conceivable level of motorcycle engine out there. From the most basic, gentle beginner bikes that are designed to be forgiving and approachable, all the way up to mind-bending engineering feats that push the boundaries of what we thought was physically possible, almost bordering on violating the known laws of physics. Get ready for a ride through the heart of the machine. So let's peel back the layers and get to the absolute core of what makes any motorcycle engine tick. At its fundamental heart, every single internal combustion engine in a motorcycle is designed to achieve one primary objective. It's about transforming minuscule yet powerful explosions into usable kinetic motion. This is the magic that propels you forward. Now, you might think this sounds complicated, requiring years of specialized training and a toolbox full of esoteric gadgets. But here's the reassuring truth. It actually boils down to just 4 fundamental steps. And no, you absolutely do not need to be a seasoned mechanic or an engineering genius to grasp this. We can break it down into a simple, memorable sequence. Step 1 is the intake. The engine sucks in a precise mixture of air and fuel into its combustion chamber. Think of it like taking a deep breath. Step 2 is compression. The piston moves up, squishing this air-fuel mixture into a much smaller, more volatile space. This builds up immense pressure and energy. Step 3 is the ignition, the main event. Boom! A spark plug ignites the compressed mixture, causing a rapid, powerful explosion that forces the piston down with incredible force. And finally, step 4 is the exhaust. The engine gets rid of the evidence, expelling the burnt gases out of the cylinder to make way for the next cycle. That's it. Seriously, that's the entire fundamental process of how an engine works, from the simplest to the most complex. The magic is in the repetition and refinement of these 4 steps. All right, now that we understand the basic recipe for engine power, let's move up to our next stage of evolution. Welcome to Level 2, the single-cylinder engine. As the name clearly suggests, this is where we have one piston doing all the work, and consequently, one explosion at a time is what we get. It's a very straightforward, minimalist approach to power. You could say it's all about just vibes, simple, direct, and unpretentious. The beauty of these engines lies in their simplicity. They are incredibly straightforward to manufacture, which makes them generally very cheap to buy and maintain. They are robust, built with fewer moving parts, which means they are also notoriously difficult to kill. These are the workhorses, the reliable companions for many riders. However, this simplicity comes with a characteristic trade-off. Because there's only one dominant power pulse happening at any given moment, these engines are infamous for their vibration. They tend to shake, sometimes quite violently, like they've collectively chugged down 6 energy drinks. While this makes them fantastic for beginner riders, they're predictable and forgiving, it's definitely not ideal if you happen to enjoy having consistent feeling in your hands and feet after a long highway ride. It's a raw, unfiltered experience. Let's crank it up a notch and move into the realm of multiple cylinders, starting with Level 3, the parallel twin engine. Now we're starting to upgrade the experience. Instead of one piston, we have 2 pistons working in tandem. This means, logically, twice the explosions, or at least twice the frequency of power pulses compared to a single. The math checks out, and so does the ride. These parallel twins offer a significant improvement in smoothness and balance over their single-cylinder cousins. They're generally faster, capable of higher revs, and produce a more consistent flow of power. But here's where it gets really interesting. Depending on the specific configuration and how the crankshaft is timed, how the pistons are phased relative to each other, a parallel twin can sound completely different. You can have engines that purr like a kitten, others that rumble with a deep growl, or even some that mimic the character of a V-twin. It's like engineers looked at the basic principles of internal combustion and said, you know what? What if we made math sound cool? They found a way to imbue mechanical processes with auditory personality. Now, transitioning to level 4, we enter the world of distinct character and even more pronounced personality, the V-twin engine. This isn't just an engine that runs, it announces its presence with authority. Typically featuring 2 cylinders arranged in a V shape, these engines are known for their deep, throaty sound, their abundant low-end torque, and a unique riding sensation. It often feels like the bike is aggressively punching the road with each power stroke, delivering a visceral, connected experience. But this character comes with its own eccentricities. Much like the parallel twin, V-twins also have their own signature vibration, though often different in character. They can vibrate like they're emotionally unstable, a rhythmic shudder that some riders find incredibly engaging. And honestly, for many, that's a huge part of the appeal. It's a personality trait that makes the motorcycle feel alive, an extension of the rider's own spirit.
All right, buckle up because now we're escalating into the serious territory of inline engine configurations, where refinement and high revving performance take center stage. We start with the inline 3, often affectionately dubbed the middle child of inline engines. It strikes a compelling balance. It's smoother than most singles and twins, offers a unique torque curve, and has a distinctive sound that's often slightly underrated but very engaging. It's a bit of a jack of all trades, excelling in versatility. But then we hit the big leagues with the inline 4. This is where things start to get truly insane in terms of performance and engineering prowess. These engines are renowned for their ability to rev ridiculously high. We're talking about levels of rotational speed that make you wonder, seriously, why is it still going? The engine isn't just spinning, it's a mechanical banshee. They don't simply accelerate, they scream. The sound produced by a high-revving inline 4 is an auditory masterpiece, a high-pitched, exhilarating wail that builds and builds, pushing the rider towards the rev limiter with an intense, almost addictive surge of power. This configuration is a favorite for sport bikes and performance machines, where outright speed and a thrilling rush are paramount. The precision and engineering required to make these engines so smooth and powerful at extreme RPMs are truly remarkable, representing a significant leap in mechanical complexity and capability.
Now we are entering the apex of motorcycle engine design, a realm where engineers seem to have collectively decided that normal is a suggestion, not a rule. This is level 6, high performance. At this stage, the focus is relentlessly on extracting every last drop of performance, optimizing power, balance, and responsiveness to levels that defy expectations. Forget practicality or economy. This is about pushing boundaries. Here, you'll encounter configurations like sophisticated V4 engines, where the V angle is meticulously chosen for optimal power delivery and sound. You'll see complex crankshaft designs like the crossplane crank, famously used by Yamaha, which fundamentally alters the firing order and character of an inline 4 engine, delivering a more linear torque feel and a distinctive exhaust note. These are technologies and designs that sound like they were conceived not on a drawing board, but within the sterile, cutting-edge environment of a high-tech research lab. Every component, every material, every degree of timing is scrutinized and perfected. The result? Engines that aren't just fast, they are extraordinarily precise. They respond instantly to the rider's input, delivering power with surgical accuracy. Think of it like wielding a scalpel, a very loud, very expensive, and incredibly powerful scalpel. It's precision engineering applied to the art of speed, transforming raw power into an exquisitely controlled force. And then we arrive at the future, a paradigm shift in motorcycle propulsion. Level 7, electric motorcycles. This is where the internal combustion engine, the very heart of our previous discussions, is entirely replaced. Forget pistons, forget fuel, forget explosions, forget all the mechanical drama that defines traditional motorcycles. Electric bikes operate on a completely different principle. There are no valves, no cylinders firing, no exhaust notes.
What you get instead is pure, unadulterated, instant torque. The moment you twist that throttle, which is essentially activating an electric motor, you are gone. The acceleration is immediate, smooth, and often startlingly potent. It's an impressive, futuristic sensation that feels utterly disconnected from the mechanical processes we've been exploring. However, this new era of power brings its own unique, almost eerie quality. It's the quietness. The absence of engine noise can be a little scary, especially when you're moving at speed. It can feel less like riding a machine and more like being pursued by a silent, invisible force, like being chased by a ghost. It's a quiet power, a different kind of thrill, challenging our very perception of what a motorcycle experience should be. So, as we've journeyed through the fascinating evolution of motorcycle engines, from the humble single-cylinder to the extreme high-performance marvels, and even into the silent realm of electric power, one thing becomes abundantly clear. At the end of the day, there really isn't a single engine configuration that stands as definitively the best for everyone. Each design is a deliberate choice, meticulously engineered and optimized for a specific kind of rider, a particular riding style, and a unique set of priorities. Some riders crave that raw, visceral connection, the unfiltered feedback that comes from simpler, more characterful engines. Others seek the silken smoothness and refined power delivery of inline configurations. Many are drawn to the sheer speed and aggressive performance of high-revving machines. And then there are those who prioritize comfort and ease, who just want something reliable and smooth that won't try to shake them apart after a few hours on the road. Ultimately, the engine is an integral part of the motorcycle's soul, influencing its sound, its feel, and its overall character. So the real question we want to leave you with, the one that truly matters, is this: what kind of engine do you ride? And more importantly, why? What is it about that particular configuration that speaks to you and your passion for two wheels? Let us know in the comments below.